SS3 triol. Uses of fat and oil. They are consumed as food. 2. Oil are adding into fat to make margarine. 3. They are used for making soaps. The soap we use contain elements of fat. 4. They are used for making paints. So those are the uses of fat and oil. Soap and detergents. Soap are the sodium salt of fatty acids. They are saponification process, or they are saponification products of fats and oils. That is, they are byproducts obtained during saponification process. Also, hydrogenation of oils. In the chemistry of soap and detergents, there are 2 important processes. The first one is saponification, while the second one is hydrogenation. In the saponification process, soap is one of the byproducts. So here, fats combined with, it's neutralized with alkali, caustic alkali such as sodium hydroxide. The process on the board is known as saponification process, where fat is neutralized by an alkali, caustic alkali, to give you soap. This is the soap, and this is propane or propane 1,2,3 triol, which is also known as triol, which is also known as glycerol. This is also known as glycerol. So this process is called saponification process. Here you have your fat being neutralized by caustic soda or caustic alkali to give your soap, and propane 1,2,3 triol, which is also known as glycerol. The second important process is hydrogenation. Hydrogenation is the process by which oil is subjected to high temperature to produce fat, which is also known as margarine. The process is very specific due to the fact that it has a critical condition. What is this critical condition? The oil must be subjected to about 180 degrees centigrade in the presence of a nickel catalyst, and hydrogen is bubbled at 5 atm, which is also known as 5 atmosphere. So this is the pressure, this is the catalyst, and this is the temperature. So before your oil can be converted into margarine, which is known as the fat, the temperature must be carried out at 180 degrees centigrade in the presence of a nickel catalyst, and hydrogen is bubbled at 5 atmosphere. That is why for hydrogenation, this condition is very important and must not be interchanged. Detergents are substances that have the ability to clean an object. The structure and the preparation is embedded in the saponification process. Action of soap on an emulsifying agent is the ability of soap to crowd around each oil droplet, thereby ensuring the cleanliness. Detergents are prepared by adding sodium salt to an acid. So sodium salt to an acid gives detergent. So that is the way by which detergent can be prepared. An example of a detergent is benzene sulfonates. The mode of action of detergents is the ability of detergent to retain their cleansing properties irrespective of the type of water used. Differences between soap and detergent. Detergent does not form scum or react with hydrogen, but soap does. Detergents are neutral, whereas soap hydrolyzes to form alkaline solution. Detergent has a wider application than soap. Detergents are biodegradable, while soap are not biodegradable. When they say biodegradable, that means they can be broken down into harmless substances. So that is the advantage, one of the advantages of detergents over soap. It is biodegradable. Questions. Differentiate between saponification and hydrogenation of oils. 2. Alkanoids are produced from alkanol by what process? 3. Why does fat have a higher melting point than oil? Question number 4. Mention 2 uses of fats. Question number 5. What are detergents? Answers. Differentiate between saponification and hydrogenation. Saponification is the hydrolysis of fat and oil with caustic alkali, while hydrogenation is the process by which oil is changed into fat or margarine. Question number 2. Alkanoids are produced from alkanol by what process? Alkanoids are produced when alkanoic acid react with alkanol following a reversible reaction to give alkanoids, which is also known as ester, to give alkanoids and water. So this process whereby an alkanoic acid reacts with alkanol to give alkanoids and water is known as esterification. So the answer to question number 2 is esterification process. Why does fat have a higher melting point than oil? It is because they are composed of higher proportion of esters of saturated fatty acid, and that is the difference between fat and oil. Question number 4. Mention 2 uses of fats. 1. They are used for making soaps. 2. They are used for making paints. Question number 5. What are detergents? Detergents are substances that have the ability to clean an object. They are biodegradable, and that is the difference between soap. Also has this definition, but the difference between detergent and soap is that detergent is biodegradable. Giant molecules. What are giant molecules? These are molecules of complex entities. There are examples of giant molecules. You have sugar. Sugar are classified into carbohydrates. Carbohydrates are naturally occurring organic compounds containing carbon, hydrogen, and oxygen. To buttress more on this, it means that carbohydrate has 3 component elements, which are carbon, hydrogen, and oxygen, with the hydrogen and oxygen present in the ratio of 2:1 as in water. This is the structure of carbohydrates. So it has carbon, hydrogen, and oxygen. But the ratio between hydrogen and oxygen is 2:1 as stipulated or as they appear in this formula. The source of sugars is present in fruits such as grapes, in honey, and also in the sap of plants. Carbohydrates are classified into 2 groups: sugars and non-sugars, which are also known as polysaccharides. Sugars are subdivided into monosaccharides, disaccharides, and polysaccharides. And in a complex situation, you can also have oligosaccharides. But for the context here, we have monosaccharides, disaccharides, and polysaccharides. What are monosaccharides? Monosaccharides are simple sugars, and examples of monosaccharides are glucose and fructose. The general formula is C6H12O6. Disaccharides. Disaccharides are complex sugars because they are made up of two molecules of monosaccharides. Examples: sucrose, maltose, and lactose. The general formula is C12H22O11. Carbohydrates. Polysaccharides are non-sugars. The general formula is C6H10O5N. That is why it is called polysaccharide, because you don't have a defined value of N. Starch, in which N is the general formula, which is between 24 and 30. So N between 24 and 30. So when N is between 24 and 30, this particular formula of this compound becomes starch. So that is starch. When you have N between 2000